Hello and welcome back to App for You. In this particular video, we'll be discussing a very important problem from a linked list. Basically, we have to perform reversal of a linked list in groups of given size, right? So this particular problem is very important, and we have also discussed a similar problem wherein we had basically performed the reversal of a linked list in pairs. So initially, the problem that we have discussed earlier were in pairs of in pairs. Okay, in pairs basically means the group size is 2. So we have basically discussed the problem wherein we have to consider pairwise reversal of the linked list, right? So basically we consider every pair and we just reverse them, right? So but in this particular video, in this particular problem, what they have said is basically we have to reverse a linked list in groups of given size. So basically, given a linked list, so as this is linked list is given, so we have 1 2 2 4 5 6 7 8, and the group size is also given, that is k is equal to 4, which means we have to consider the linked list in groups. So basically consider this first group, you have to reverse it. So once you reverse it, you will be getting, let me erase it and make it more clearly. So you see, once you perform reversal of 1 2 2 4, what will you get? You will get 4 2 2 1, right? You can see this group is reversed. Again you will consider the next group and you will reverse it also. So 8 7 6 5. So you see 8 7 6 5. So basically what happens is you have to consider a group of size k and you just reverse that particular group. So you see 1 2 2 4, so I reversed 4 2 2 1, done. 5 6 7 8, so I reversed this as 8 7 6 5, done. And these two are connected. So this is how we basically have to understand this particular problem and have to basically come out with a solution to solve this particular problem. So again we will be considering the concept, or we will be following the same concept that we have been using when we were basically reversing the linked list in pairs. Okay, in pairs. So basically what is the concept that we have discussed earlier? So let me just increase the size of the screen. Okay, it seems fine. So considering the concept that we have been discussing while following the reversal of linked list in pairs. So basically suppose we have a linked list 1, right, 2 2 again, 4 5 6 7 8 followed by null. Fine, our head pointer is pointing to this particular node right now. This is given, this is what data that is they have provided, that is this is the data they have provided. Now we need to basically perform reversal group wise. So remember, we have earlier used 3 pointers for our help. What were the pointers? The pointers were basically, I'll be declaring them as struct node p1, fine, struct node p2, great, and one more pointer that I'll be using is struct node h, right? So if you remember, the h was basically pointing to the first node right now. Okay, h was pointing to this, p1 was pointing before h, p2 was pointing after h. So we have discussed, we have been following this concept, okay, while performing the reversal in pairs. We will do the same thing right now also. So what we will be doing is basically, initially we will initialize p1 is equal to null. Okay, you will initialize p2 also equal to null, not an issue, we will be changing it right now, and h will point to head. So you can basically see that our h is basically pointing to the head node right now. Okay, now what will happen? Now you see right now p1 and p2 both are null. Okay, p1 and p2 both are null. Now what will we do? Now we have to basically perform reversal in group wise. So in this particular video we will be solving this particular problem using recursion. So first of all, I'll be considering the first group, this group. Now how to reverse this particular group? In order to reverse this particular group, I'll just consider this group, okay, and I will traverse till this point and I'll just reverse the direction of the links. So for doing so, I'll be taking the help of these pointers p1, p2 and head. Now how will it work? See, right now h is here, so basically we have to traverse till this particular point. Now how will I understand what is the particular point? So basically the value k will help me know what is the size of the group. So for that particular reason, I'll be using a counter. Integer count is equal to 0, which is initially 0. Now I'll create a while loop which will say that while count is less than k and the node h is and the pointer h is pointing to a valid node not equal to null, what would happen? I will just come inside and say, okay, now since I want to reverse the direction of this link, so right now see I'm in this particular point, right? So I want to reverse the direction of the next pointer to this. So right now next pointer is pointing to this node 2, but I want to reverse the direction of this pointer to previous node. But before that I should preserve the address of this particular node. So for that particular reason I'll be doing p2 equal to h next. So what will happen? I'll basically, by doing this, keep track of the node following this particular node. So basically p2 comes here. So p2 comes here. Getting the point? So p2 comes here. So let me just erase this. You see, h is here, p2 is here, right? Right now current value is 0, means count value is 0. What will I do next? Once I have preserved the value of node p2, node to which p2 is pointing, now I can basically say h next is equal to p1, which means I am performing the reversal. Okay, h next is equal to p1. So this now will point to p1, and p1 is what? Null right now. Now what should we do? This was h, this was p2. Now the p1 should now come to the position of h. Okay, and h should now move to the position of p2. Getting the point? Which means, and we'll perform count plus plus. So what happens? You see, right now h was here. I did, while h is not equal to null, true, count is also less than k because count is 0. I came inside p2 equal to h next. So basically p2 will point to this node following h. Then p1, then h next equal to p1, which means it will perform reversal. It is pointing to the node previous to it. Right now it is null. Okay, and h equal to p2. So now h will point to p2, but before that you see p1 is equal to h. So once I do reversal, immediately after reversal p1 will now come to this h point. H will now move to the next node, that is p2, and now count will increase by 1, which indicates that we have now just done one reversal. Okay, now again count is less than k, true, h is not equal to null. This is also true because h is pointing to 2, count is also 1, so true. Come inside p2 equal to h next. So h is right now pointing to this 2, p2 will point to this particular 2. Then h next equal to p1. So what does it indicate? Let me just erase this and show you. So far what has happened? So far we have just reversed this one reverse. Okay, this link is pointing to the node previous to it. Okay, so let me make it more clear. This was h, so h next is equal to previous. So this was the one first time this has happened. Now the next time h next equal to previous one, so 2 will point to 1, right? 2 will point to 1. What will happen next? p1 equal to h. Now p1 will come this particular point. H equal to p2, h comes here. Count plus plus, count becomes 2, because see, this is the second time I have reversed the link. Now what will happen? Again count is less than k is true, and h is also not equal to null. This is also true. p2 will point to the node following h. So p2 will basically point to the node following h. Why am I doing so? Because I want to preserve the address of the following node following me while I am reversing. Now since I have already saved this particular address, now immediately I can reverse it. So I will again do h next equal to p1. So this next equal to p1 pointing to the previous node. p1 equal to h. Now p1 can come here. H equal to p2, h can come here. Count plus plus, count becomes now 3. So this was my third reversal, right? Now again you see, h is not equal to null is true, count is also less than k, because k is right now 4, right, in this particular question. So it is valid. So what I can do? I can say, okay, move p2 to h next, right? p2 equal to h next. So basically p2 will point to h next. Now h next equal to p1. So this is h next equal to p1, which means I can just point this to previous node. Done. p1 equal to h. So now I can update position of p1 to this particular point. H is equal to p2. H will come to this particular point. Count plus plus, count moves to 4, right? So basically this was the fourth time I am updating. Now what happens? Now when the control goes back to this particular loop, it says count less than k, and I will say false. Why? Because count is right now 4 and it is not less than 4, because k is 4, right? False. You come out. The moment you come out, what should we check? The moment we come out, we should check if there is any node after this group, right? Because you see, right now we are coming out means we have reached the end of the group, right? Our pointer p1 is pointing to the last node of this particular group, right? The last node of this particular group. So okay, but right now this has become head. This will become head now, isn't it? The p1 pointer, and you see h is pointing to 5. So basically I'll say if h. What does it mean? If means that if h is not equal to null, right? If h is not equal to null, or you can say if there is some node present in h, what can I do? I can simply say that if h is not equal to null, then if h is not equal to null, you see right now, after performing this all operation, what is the status of the linked list? The status of the linked list is 4 followed by 2 followed by 2 followed by 1. Okay, and there is some another separate list 5 6 7 8 null. Considering the pointer, now h is pointing to 5, fine. P1 is pointing to 4, so basically P1 is pointing to this. And you remember the head node that we had passed, it is still there, isn't it? Head is pointing to 1, node 1, and there is no linkage between these two. But I know I have to create a linkage between these two. So for that particular reason, what will I do? I'll check if h is not pointing to non-null node, means if h is pointing to some valid node, it indicates that there is a possibility of some group following this group. So what will I do? This particular head next, so I'll write here basically head of next will be equal to what? It will be equal to the recursive call on this. Okay, I'll do the recursive call on this particular group again. So basically I'll just pass the head pointer of the following group. So wherever h is pointing, I'll pass that address. So means I want to, that will be now, that is what I'm saying, right? Because head is now pointing to this particular node, right? So it is still pointing there, and I want to decide what will be the next of this. Now the next of this will obviously be decided once we reverse this particular group, right? Once we reverse this particular group. So for that specific reason, I'll say h head next is equal to basically the reverse, that is the recursive call, because the function name is reverse, and I should pass the head node. So basically right now my head node will be this particular value h, because h is pointing to this node 5, isn't it? And what next? And I should also pass the value of k, because it is expecting me to pass the value of k also, an integer that indicates the size of the group. Fine. Now after this, what should basically I return? Now suppose if there was no suppose if there was no group following it, so basically head was pointing to null. Right now head will point to null, this is null, head would point to null. Now if head would point to null, this would not be executed. But are we complete? No, we are not complete, because we have to return the address of the head node of the linked list. Now what would be the address of the head node of the linked list? You see basically right now, while I performed a reversal on this particular group, where is P1 pointing to? P1 is pointing to the starting node of this group, right? P1 is pointing to the starting node of this group, and so basically 1 would point to the starting node of the next group. If suppose there are some nodes present, then 1 would point to the starting node of the next group. And how will I find the starting node? Basically after performing this operation, wherever this P1 is pointing, okay, after this has completed this execution, wherever P1 is pointing, that basically indicates the starting position, right? So I'll say return P1, right? Return P1, because this return P1 will only indicate the starting position of the linked list. Fine. So yeah, that's all. I think it should work fine. So let us just compile the code. Okay, so yeah, I think this is a mistake. It should be small n, right? Because in the structure they have declared as small n. Let me just erase this small n. Okay, you see, because in the structure they have declared small n. Yeah, so you can see the output is already in front of us. The node has been reversed, 4221 8765. So this was one of the very easy method of solving this particular problem. The time complexity is obviously order of n, because we are just doing one traversal. Considering the space complexity, so time complexity is order of n, fine. Space complexity, basically we are using some extra space. Now how much extra space are you using depends upon the number of recursive calls. How many number of recursive calls will be there? You see, it depends upon the number of groups present. Now how many number of groups will be here? Now total number of nodes will be n. The size of each group is k. So basically order of n by k. So basically this much groups will be present, and you know, for every group we are going to do a recursive call. So space complexity will be order of n by k, right? So can it be made more efficient? Obviously there is an efficient approach, so we shall be discussing that also. But from this particular video, that's all from my side. I hope this video was helpful. In case of any doubt, please put your doubts in the comment section, and just like, share and subscribe. Thank you.